Hello.
Hi,
Hello, good morning.
good morning.
How's everything going?
Pretty good so far, just a lot to do.
I know it's that time of the year, huh?
Yeah,
Okay, we'll get started at around 10. So
okay.
people are queuing up in the waiting room.
Okay. Mm, who that? Is that mom?
Okay, guys, we'll start in a couple of minutes. It's almost 10 o'clock. And congratulations to all those Dodger fans out there. They got by the skin of their teeth, but they did it, didn't they? So, as you know, I'm a big Padres fan, but I'll root for the National League in the World Series, even though two of my favorites, Hunter Renfroe and Manuel Margot, are now playing for the Rays. So may the best team win. Good luck, Dodger fans. Okay, let's get started with this one now. This is a student's submission for the practice test. Now, Noah, you did ask me if this is going to stick in the grade book. And I said no, but it does appear in your grade book, doesn't it? But it won't count for your grade. Okay, so it's a practice test, wasn't meant to be part of your grade. So I'll take that out when I calculate your final grades for the class. Now this next test will count. The midterm test that I give to you on Thursday will count. All right, now let me just report to you a few statistics for your MyLab. In checking your completion rate, it shows 47% complete. That's the overall completion for all students in the class. Is that good or bad? Well, neither. It's about on pace. We'll check it again in a couple of weeks to make sure that we get that number up. Right now, it's 47% complete. Some of you are farther along than that. Others are not as far along. That's just the overall. It's like the sample mean, right? It gives us sort of a picture, but it doesn't tell us the entire picture. So 47% completion on your homework. And for the practice test, about 40% of you submitted a practice test. It was due this morning by 10 o'clock. When I recheck it, I may see some last minute completions there. But remember, the practice test is for your benefit. So, you know, maybe some of you attempted it, didn't get very far, did not submit it. I think for this practice test, you were allowed up to 3 submissions, okay? And so, again, it's for your benefit, and hopefully it serves its purpose to help you prepare for the actual test, the actual midterm, and then we'll do the drill again at the end of the semester for the final exam, all right? And then what was the test average of those who actually submitted the test? Well, according to Gradebook, the test average was 74%. So that's not bad. Okay, that's in the C range. And I know some of you are saying, oh, I could have done better. And there is a review mechanism in your test. It'll take you back through, and that's what we're going to do now. I'm going to show you one student submission, and we'll go through each of the attempted solutions and to see how the student did. Okay, so I've got it up here on the screen. Can you all see it here? Yeah. Okay, so let's go through each of these 30 problems. I think we'll have time. And now the questions are randomized, and each time you resubmit, you get a new exam. It's covering the same topics, concepts, exercises, problems, whatever you want to call them. But the numbers are changed up a little bit. And those of you who resubmitted saw that occurring, where you didn't get the same test all over again. You got a test that was similar, but it wasn't exactly the same test. So, so here's a submission that we got. Okay, so let's go through this one. So there's a big red X here. What happened there? Well, the student forgot to answer the question. 2 events, A and B. And remember, this is the review. Okay, this is a review of the submission. So when you go back in and review your submission, it'll show correct if you've answered correctly. And it'll give you partial credit if you've answered the question partially correct. Okay. So in this particular submission, the student did not answer the question before he submitted the test. So 2 events A and B are blank if the occurrence of one does not affect the probability of the other. And the correct answer is independent. Okay? And if you hit this red triangle up here in the corner, it'll give you some feedback here. All right? So the student did not answer. Okay? All right. Second problem. What does P of B given A represent? So you're given multiple choices here, and you have to select the correct choice. And this student answered correctly. C, the probability of event B occurring after it is assumed that event A has already occurred. Okay. And if there are any questions about any of these, please stop me and we'll go over it. Okay. Here's a frequency table or a frequency distribution for a random variable X. And you know that if it's a bona fide probability distribution, this column P of X, which is the probability that X is equal to X, that should be the sum of that column. The sum of the values in the column should add up to 1. So your problem is, does the column add up to 1? And if you add these up, you see that it does not add up to 1, does it? Okay? And if you add them up, you'll get something about 77.5%. So no, does not add up to 1. Okay, this one was answered correctly. P of A plus P of A bar is 1 way to express the rule of complementary events. And again, there was a multiple choice here, and the correct answer was, you know that if 2 events are complementary, then the sum of the probabilities P of A plus P of A bar is always equal to 1. All right. And next problem here. Notice that this is the standard deviation for a binomial random variable whose parameters are n equal to 180 and p, which is given to be 1/4. Okay. Remember, q is always 1 minus p, so in this problem, p is equal to 1/4, so q is 3/4. And if you multiply and take the square root of NPQ, you get the standard deviation for the binomial. And in this problem, it turns out to be, so we'll take 180, we'll multiply by 1/4 times 3/4, put that into the calculator, take its square root, and we get 5.8. Now, remember that you must follow the directions here. So if it tells you to round to 1, 2, 3, or 4 decimal places, you have to place your answer. You have to round as instructed. Okay? So here it says 1 decimal place. So when you calculate this in the calculator, let's see, let's just do that here for a second, and then we'll round it to 1 place. So we're going to take the square root of 180, and I'll just write decimals here, times 0.25 times 0.75, and our answer is 5.80947, and it goes on. So if I round that to 1 decimal place, I get 5.8. Okay? So remember to express your answer according to the instructions here, and the instruction is to use 1 decimal place. So that irrational number, which has a non-terminating, non-repeating decimal expansion, just to round it down to 1 place. Okay? All right. Any questions so far? Okay, let's keep going here. All right, now here's the mean for the binomial. And in this problem, the mean is NP, and we're given N is 1549, and P is 3/4 or 0.75. Okay, and the instruction is type an integer or a decimal. Turns out to be a decimal. And there's no rounding here. So if you plug in the product, 1549 times 0.75, you get a decimal out to 2 decimal places, okay, which is 1161.75. Okay, all right. In the next problem, you're given IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Okay. And you're asked to calculate the area in the shaded region of the graph, and that graph is the normal distribution, whose mean is 100 and whose standard deviation is 15. Okay. And so you went to StatCrunch, you went to your calculator, okay. And here in StatCrunch, you plug in a mean of 100, a standard deviation of 15, and we want the probability or the area under the graph between two values. Okay, let me just check again, 70 and 125, all right? Okay. So let's plug in 70 here. And 125 over here. Okay, and we see the shaded region with probability or area under the curve. And again, we're going to have to take this number, 0.92945952, and we'll have to round it according to their instructions. Okay, so let's take that value and go ahead and round it. All right. So 9294. If we round it to 4 places, it'll be 9295. Okay. And there you see it there. Okay. Rounded to 4 decimal places. Okay. All right. Okay, so again, you're given a normal distribution with given parameters, and you have to calculate an area under this curve. And you did that in StatCrunch, hopefully, okay? You could do that from your tables. But now that you're more than familiar with StatCrunch, you can see that StatCrunch will give you the answer straight away. Okay. Okay. All right. And now here's a problem where we're given the area under the curve, and we have to calculate the probability in this right tail for an unknown x. And that probability has to be 0.6. And the student got it wrong here. All right. And the reason was possibly the area might have been mistaken in StatCrunch. Okay. So again, we have the value x such that in the right tail corresponding to x, we get the probability 0.6. All right. So again, if we go back to StatCrunch, we want the right tail probability. So we'll go to standard up here, and we'll specify the right tail probability to be 0.6. Okay. And I'll switch the inequality here to be right tail. And there we get the 96. Okay. All right. So again, using your StatCrunch calculator, you can easily calculate the value x, for which the area under the curve, under the PDF, is 0.6. Okay, any questions? Any questions about any of these problems? We're good? Now remember, the problems that you solved in your test are not the exact same problems, are they? The numbers may be a little different. But as you go through your review of your submission, you'll get an output that looks like this, like we're going through. Okay. All right, next problem. Okay, use the following results from a test for marijuana use, which is provided by a certain drug company, a drug testing company. Okay. Among 140 subjects with positive test results, there are 24 false positive results. Okay. So of those 140, even though the test came out positive, those 24 individuals are not marijuana users. Okay. For the negative results, it turns out that there were 5 false negative results. In other words, in that group of 152, it turns out that there were 5 who are marijuana users. And so in part A, how many subjects were included in the study? Okay. So we add up the 140, and we get here 292, the incorrect answer of 296. Okay. All right. So if we add up the 140 with the 152, we get the 292, not 296. So that was an unforced error, so to speak. Okay. Somebody didn't use their calculator. Instead, they just did the mental addition. Okay. All right. And how many subjects did not use marijuana? All right. Okay. So remember, of the 140 that tested positive, actually there were 24 who were false positive. So we'll take that 24 out of the 140. Okay. And if you do that, you get the 171, the 140 there. So yeah, 140 are positive, there are users, and there's a total of 171, not 176. Okay. All right. Mm-hmm. 147. Okay. So to get the 171, there were 2 groups of subjects that did not use marijuana, those who tested negative, and the result was not a false negative. Okay. And those that did not use marijuana are 152, and you have to subtract out the 5 to get the 147, and then you add back in the 24. Of the other group that were false positive, that is, they are marijuana, they are not marijuana users, 24, 140 minus 24 gives us the 116, and then we add in the 34, so we get the 171. Okay. All right, and then what is the probability that a randomly selected subject did not use marijuana? And since this answer up here, 176, was incorrect. By the way, if you, again, don't follow the instructions in terms of rounding, you may be docked. Now here, the answer was given as a fraction. Okay. Remember from your MyLab statistics, you can express your answers in fractions, but the instructions ask you to calculate the answer in 3 decimal places. All right. And so when you take the correct numerator and the correct denominator here, okay, which would be 171 over 292. So 171 over 292 and that's equal to 0.5856164. So we're going to round that answer down to 3 decimal places and we get 0.586. Okay? So not a difficult problem, but there is a little bit of bookkeeping to do here. And it's just a good idea to recheck your answer before you submit it. Okay? Use your calculators even though it appears to be simple addition. Okay? If our minds are racing too fast, we may make an error here. The calculator is much more reliable, even though it appears that we could do this quick and easy mentally. But the reliability of doing that way is a little less. So check your answers using a calculator. Okay. When using the addition rule, always be careful to avoid double counting outcomes. Now remember, the addition rule is what's the probability of A or B? It's the probability of A plus the probability of B, but then you have to subtract out the probability of A and B, all right? So you have to remember to account those double probabilities that you get when you intersect A with B, because you're going to get probability of A is going to include the intersection with B, and the probability of B will include the intersection with A. So you have to subtract out one of those to get the right answer. Okay? All right. Moving on. Selections made with replacement are considered to be independent. All right? Okay, in the next problem, there are 15,958,866 adults in a region. Okay. Now notice in this problem, the student answered the problem partially correct. We'll go through each of these parts here. Okay. If a polling organization randomly selects 1,235 adults without replacement, are the selections...
Shut up.
Sorry about that. Okay, so if a polling organization randomly selects 1,235 adults without replacement, which is normally what you would do, right? Are the selections independent or dependent? And the correct answer is that the selections are dependent, because when you reduce the population by the samples and you're not replacing, then it may change the characteristics overall of the sampling. Okay. The student selected B, which was the selections are independent because the sample size is small relative to the population. Well, that's partially correct, but the correct answer is that they're dependent, because we can't always assume that the sample size is no more than 5%. Okay, so if we knew that, okay, then we could proceed. If the selections are dependent, can they be treated as independent for the purposes of calculations? And in that case, we look up here, we take the ratio of 1,235 to almost 16 million, and you see that that ratio is much smaller than 5%. Okay, let's quickly verify that. 1,235 divided by 15,958,866. And you get something out to 1, 2, 3, 4, 5 decimal places. So it's 10 to the minus fifth. It's 7.7 times 10 to the minus fifth, which is much less than 0.05. Okay. So we answer yes because the sample size is less than 5% of the population. Okay, number 13. Here we have a z-score. We're given mu and sigma. We're given x. And we're asked to calculate the z-score for x. So again, your numerator is the difference between x and mu, which is negative 0.9. And then we divide by the standard deviation, 2.7. And if we divide negative 0.9 by 2.7, we get negative 0.70. Now here, I'm a little bit fuzzy on representing that number as 0.7 or 0.70. I have a feeling that if you answered 0.7, it would probably give you a wrong answer because it's instructing you to use 2 decimal places. So that's why the student expressed it as minus 0.70. Okay, that's an exact decimal. But notice the student did write it out as a 2 decimal expression, negative 0.70. So be careful with that one, okay? Okay. All right. Okay, let's move on now. Okay, so here we have the binomial distribution. We've talked about n choose x. That's an integer that's on your calculator. So this gives us the probability that x is equal to little x, where big X is a binomial distribution with parameters n equal to 5 and p equal to 0.3. So what we're calculating here is for this binomial distribution, what is the probability that x is equal to 1? And we can do that in StatCrunch, or you can calculate this using your calculators. But let's go to StatCrunch. And we'll calculate it right in StatCrunch using the binomial calculator. All right. So let's go down to Stat, Calculators, choose Binomial. And we'll type in n equals 5. Our probability of success is 0.3. And we want the probability that x is equal to 1. Okay? And there we get the 0.36015. Now, as I just mentioned, you can do this on the calculator. But now that you're familiar with StatCrunch, you can easily calculate this in StatCrunch. Okay? So recognize that the problem is asking you to evaluate the probability that x is equal to 1, where the random variable x is binomial with parameters 5 and 0.3. All right. Any questions yet about any of these problems? We're about halfway done. Okay. So let's continue. Okay. Engineers want to design seats in commercial aircraft so that they are wide enough to fit 95% of all males. Accommodating 100% of males would require very wide seats that would be much too expensive. Let's see. Men have hip breadths that are normally distributed with a mean of 14.9 inches and a standard deviation of 0.9 inches. So we want to calculate P sub 95. That's the 95th percentile. So under our normal curve, we want to put 5% in the right tail. And the x corresponding to that value on the x-axis will be P95. Okay? So let's go back into StatCrunch. Okay. Bring up our normal calculator again. Fill in our parameters. The mean is here, 14.9. The standard deviation is 0.9. And we want the 95th percentile. So we're going to, we can use less than or equal to. And so we want the probability in the left tail to be 0.95. Okay? And that'll give us our P95. Okay. And again, we'll follow the instructions on decimal places. Okay. So for this one, it says round to 1 decimal place. So in StatCrunch, we'll take our probability, I'm sorry, our value x, and we'll round it down to 1 decimal place. So you can see it'll be 16.4, okay? And that's the correct answer. Student got that right, okay? Any questions about this problem? We're told that the hip breadths and inches are standard, are a normal distribution. We're given the normal parameters, mean and standard deviation, and we're off and running. We can go right into StatCrunch, use our calculator for the normal, and calculate the 95th percentile.
Professor, I have a question.
Yes.
About that last problem. How can you tell if it's a left tail test or a right tail test?
Well, we're not doing any test here. All we're doing is calculating an x value. And so you have to understand what this means here. right? P sub 95 is a percentile. P sub 50 is the median. So in a distribution, the percentile is simply a value on the x-axis such that the probability that the random variable x is less than or equal to P sub 95 is 0.95. Okay? All right, let me just take a moment here and sketch that in our whiteboard here. Let's see, where did my whiteboard go? I'm sorry, let's see if we can get to the whiteboard here. Here it is. Can you see the whiteboard now? Okay, so here, okay. Well, I'm sorry. I think I'm doing the right things here, but oh, okay. We're not on the whiteboard for some reason. Yeah, okay. My bad. I have to see. There it is. I think this is it. Well, okay. Do this one more time. Well, let's see. I do have a document here that I think I can. Oh boy. Now I'm having problems here getting my whiteboard up. Sorry about that. Something to do with resume share. Okay. Yeah, it won't let me stay on the whiteboard. I'm sorry. Let's see. Let me, let's go back to, so if I could sketch this out for you, you'd see that the area to the left of P95 is 0.95, okay? Which means the area to the right in the right tail is 0.05. So when you see this notation, P95, you see that it's just a value x such that the probability to the left of x is 0.95. And as I just showed you in StatCrunch here, look at this shaded area.
Professor, there's nothing on the screen.
Oh, okay. Let's see, let me, Is that okay now? Is that good?
Yeah, we can see it.
Okay. All right, so P95 is this value right here, right at the edge of this shaded area. And you can see that the area to the left of that value X, which rounded to one place, is 16.4. That area is 0.95, approximately. Okay, so let's just do it this way. Let's type in 16.4 and compute the area to the left. To the left because it's less than or equal to. So everything to the left of this number, if we shade that area, we'll get about 0.95 because we've rounded. Okay? Now, we can also do this in the following way. We'll specify 0.95 area, 0.05 area in the right tail. So I'm going to reverse that inequality there. And you see you get the 16.4 again, rounded to one decimal place. So this value X equal to 16.4 leaves approximately 0.05 area to the right and 0.95 area to the left, because we know that the entire area under the whole curve is 1. It's a PDF, okay? All right, and sorry I couldn't bring up the whiteboard there. Wasn't behaving for me.
Thanks, Professor.
Okay, you're welcome. I'll get that straightened out for next time. Okay, so here we have a table. We've used these data tables before. And this table lists drive-through order accuracy at popular fast food chains. And we're going to assume random selection, okay? So we'll assume that orders are randomly selected from those included in the table, okay? So we have these 4 drive-through restaurants, A, B, C, and D. And you get home and you open up your food and it has onions on it and you didn't order onions. Okay, that's happened to us one form or another, to all of us. All right, so so this first row in the table gives you the number of orders accurate by restaurant, okay? And then in the second row, this lists the number of inaccurate orders. Okay, and notice that the percentages are not small, are they? It happens more than we'd like to admit. All right. So what's the probability of getting an order that is not accurate? All right. So you can see here that in this problem, what we would do is take the orders that are not accurate and the ratio of all of the orders. Now, to get all of the orders, you'd have to add down the rows. So your denominator would be the sum of this first column sum plus the sum of the second column sum, and so on. That would be your denominator. And then you would add up your orders that are not accurate, 34 plus 53 plus 30 plus 19. That would go into your numerator, and then you take the ratio. And the student gave an answer in a fractional form, okay? And the test said that was incorrect. Let's just double check what 17 divided by 139 is. Okay, and notice that it's correct. It is 0.122 rounded to 3 decimal places, but the student expressed it as a simplified fraction. Okay, again, taking the sum of the columns, adding those up, and then taking the sum of the second row, adding those up, taking the ratio, leaving it as a fraction, and the answer was incorrect because they did not express the answer in 3 decimal places. Does everyone see that? Did anybody get docked because you did not round properly according to the instructions? Okay. I'm sure some of you may have been docked a point. All right. And so on your midterm on Thursday, please remember these little gotchas because they will affect your overall grade. Okay. All right. Okay, so let's move on. Now, here is a z-score for a given x bar and a given mu and sigma and n. So given all of those parameters, we can calculate the z-score for the sample mean x bar, whose value is 46.6. The given mean is 46.1. Sigma is given to be 3.3, and n is 16. So plugging those values into your z-score, and remember to round to 2 decimal places, okay? And then submit your answer as 0.61, okay? Here's another binomial probability. Recognize this expression as a binomial probability whose parameters are n equal to 5 and p is equal to 0.2. And remember to round to 4 decimal places. So let's go into StatCrunch, take out our binomial calculator. It's right here under stats. Stat calculators, binomial. And now fill in our parameters here. N is equal to 5. P is 0.2. And we're calculating the probability that x is equal to 2. So I'm going to change that inequality to equals. I'll type in a 2 here, and I'll get a probability of 0.2048. Okay, and that's already expressed in 4 decimal places, so I'm good to go with 0.2048. All right. Okay, so again, don't be fooled by this expression here. It's simply a binomial probability for the given parameters when x is equal to 2. And now go into StatCrunch and calculate that probability. Okay, here's a normal probability for IQ scores. We're told that the mean is 97.9 with a standard deviation of 15.1. Find the probability that a randomly selected adult has an IQ greater than 127.6. Okay. And then round to 4 decimal places. Okay. So let's go into StatCrunch. Use our normal calculator here. And our mean for this distribution is 97.9. Our standard deviation is 15.1. And we want to calculate the probability that the IQ score exceeds the value 127.6. And now compute that probability. Okay? And then we'll round it to 4 decimal places as instructed. So if we round this to 4 decimal places, we get 0.0246. Okay. Insert our answer, and it's correct. All right, here we're going to calculate as instructed 2 standard deviations above the mean, mu plus 2 sigma. Mu is 2.8, sigma is 1.4. Put that into the calculator. It says do not round. So you insert the answer of 5.6. Okay? 2 times 1.4 is 2.8, and then 2.8 plus 2.8 is 5.6. Here you have a value expressed in factorials, and this value is nothing more than n choose r, where n is 17 and r is 12. This is the number in front of your binomial probability distribution. Okay? All right. And it counts the number of heads equal to 12 in 17 tosses of a coin, where the outcomes are heads and tails. So let's go to our TIX36 Pro, and I'm going to type in N, which is 17. I'll hit NCR, and then type in 12. And when you do that calculation on your calculator, you get 6,188. You could also do this in the following way, which I don't recommend. 17 factorial is 1 times 2 all the way out to times 17. So you can cancel 12 factorial, and in the numerator you're left with 13 times 14 times 15 times 16 times 17. And then down here you have 17 minus 12, which is 5 factorial. 5 factorial is 120. So now you can cancel out common factors from top and bottom and get the 6188. But your TIX, your TI36X Pro has that key on the calculator for you. Some of you have calculators that don't have that key, but you can still do it arithmetically because you know the definition of factorial. And then you can cancel out common factors, numerator over denominator, and you'll get the same answer, 6188. Here's another problem. X is the 99th percentile in this distribution of IQ scores of adults. We're told that the IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So we're supposed to calculate the 99th percentile here, okay? All right, so let's go back in and then let's see. We have to round to 1 decimal place. So let's go back into StatCrunch. Here's our normal distribution. And in this problem, we're told that our mean is 100 and our standard deviation is 15. And we want the 99th percentile. Let's just change that to less than or equal to. We'll specify our probability on the left, the right side here to be 0.99. And now that'll give us our percentile, our 99th percentile. Okay. And there you see the 99th percentile as 134.8952 if we round it to 4 places. 134, oh, we have to round it to 1? Okay, I'm sorry, we round that to 1 place. And if we round this decimal to 1 place, we get 134.9. 134.9. All right. And there's our answer. Student got it correct. Okay. Here's a problem in calculating the mean and the standard deviation for this table here. Now, let's just do a quick check here. All the probabilities are between 0 and 1. And furthermore, if we take the calculator and add up all of these 6 probabilities here, it will be 1, or very close to 1, okay? Within, let's say, 1 or 2%. And so let's go ahead and use our definition of the mean of this distribution. We'll take the product in the top row and multiply it by its corresponding probability of X in the second row and add those values up. Okay? Student got this partially correct. The mean out to 4 decimal places is 0.8001. However, the standard deviation is 0.8199 to 4 decimal places, and the student miscalculated. Okay? So the program would give you a correct answer if you answered 0.8199 plus or minus 0.001, 0.8198 plus or minus 0001, okay? Why did the student get this incorrect? Well, the formula for the standard deviation is given here. And you can see that it's fairly intensive to calculate it, even with as few as six probabilities here, okay? So using this calculating formula for the standard for the variance, excuse me, this is the variance. If I said the standard deviation, I meant the variance, okay? Remember, the standard deviation is the square root of this value. but you're not calculating the square root, you're calculating sigma squared. Okay. Any questions about this problem? Some of you may have been docked because your calculation was off. So recheck it. And I'll give you enough time on your midterm so that before you submit it, go ahead and recheck all your answers. You know, and you'll have to do that answer by answer, because once you submit it, then you can't go back in and change that submission. You'll have to retake the test all over again. And some of you did that. You took it more than one time, which is fine. Okay. All right. And this problem here, number 24, in number 24, how do we do this one? Let's read it first. Among 6,693 cases of heart pacemaker malfunctions, 312 were found to be caused by firmware. Firmware is the software programmed into the device. Okay. If the firmware is tested in 3 different pacemakers randomly selected from this batch of 6,693, and the entire batch is accepted if there are no failures, what is the probability that the firmware in the entire batch will be accepted? Okay. Is this procedure likely to result in the entire batch being accepted? Okay, well, first of all, we're going to check, we'll calculate the number of functioning pacemakers, or the total number of pacemakers. Okay, now the total number here is just the number here, 6,693. That's given to us in the problem, right? And out of those 6,693, if we subtract out the 312, which malfunctioned because of firmware, we get a value of 6,381. Okay? If we take that ratio, 6,381, 6,381, all right, then that gives us the number of functioning pacemakers because of good software, right? 312 out of the 6,693 didn't function because of the software. The rest of them were functioning. So we take the difference, 6,693 minus the 312. And so if we randomly select the first pacemaker to be inspected, the ratio 6,381 over the entire number 6,693 will give us the probability of randomly selecting a good pacemaker. Okay? Then we select a second one. Okay? Now, assuming that we selected a good pacemaker on the first trial, there are now one less good pacemakers, which is 6,380. And since we don't draw with replacement, That means there are fewer total, one fewer, that's 6692. And we take the ratio 6380 over 6692 and multiply. And then we do that a third time. And the third factor is 6379 over 6691. Okay? So if you multiply those three fractions together and round to 3 decimal places, you get the 0.867. Okay, again, the number of good pacemakers, that is the number of pacemakers that don't malfunction because of firmware, is 6693 minus 312. All right, so the probability of selecting a good one is simply that difference, which is 6381 over 6693. Now multiply that times the next fraction, which would be 6380 over 6692. And then multiply that by the third selection, and the probability of a good pacemaker would be 6379 over 6691. And the product of those three fractions, rounded to 3 decimal places, is 0.87. Okay? Any questions about this problem?
Where are you getting those follow-up fractions? Like, I understand where you got the first one, the 6693, you subtract out the 312, and then that's the numerator. But you were saying in the next, like the 2 fractions following that one that you multiply across, that I think you said the numerators were 6692 and then 6691.
Yes. That's because you're testing without replacement. So each time you test these 3 pacemakers that don't malfunction because of firmware.
Mm-hmm.
So if you've already selected one on your first trial, how many do you have left for the second trial?
I see, just one less.
One less.
Mm-hmm.
And so it's a conditional probability because you're removing one that has been selected as good. That reduces that number by 1. So your numerator reduces by 1.
I see.
And then you multiply those 3 fractions. And please do that, check it, and make sure that you get the answer 0.867, okay?
Alrighty.
It's a quick calculation on your calculator. Now, remember the TI-36X has a key there which has a box divided by a box. So you can easily build a fraction by populating the numerator in the top box and the denominator in the bottom box. So in your top denominator, your top box, you have the product 6381 times 6380 times 6379. And then in your bottom box, you have 6693 times 6692 times 6691. Round that to 3 places, and you'll get the 0.867. Try that before we leave today, just to verify it for you, okay? Okay, and here's the standard deviation for a binomial with parameters 1528, and p is 2 over 5. So again, plug that into your calculators. make sure that you round it to the correct number of decimal places here. The test is asking you to round it to 1 decimal place. Okay. And your correct answer is 19.1. Student got that correct. In this problem here, it says, suppose that the sitting back to knee length for a group of adults has a normal distribution with a mean of 22.9 inches and a standard deviation of sigma equal to 1.1 inches. These data are often used in the design of different seats, including aircraft seats, train seats, theater seats, and classroom seats. Instead of using 0.05 for identifying significant values, use the criteria that a value x is significantly high if the probability x or greater is less than or equal to 0.01. Okay, x or greater. So you're looking at the right tail. So what's the probability that you get a value x or greater? And if that value is less than 0.01, then it's considered significantly high. Okay? It's way out in the right tail, so it's too high. Similarly, if it's way out in the left tail, it's too low. Okay? So we want to find these two values x, all right, one on the left, one on the right, and everything in between has a probability of 0.99. 0.98, I should say, because each tail has 0.01. So the interior between the lower x and the higher x should have a probability of 0.998. So let's go into StatCrunch and find those two x values. Okay? So we'll choose between. Our mean here for this normal distribution is 22.9 inches. Our standard deviation is given to be here 1.1. And now we want two values x so that the tails, the left tail and the right tail, each have 0.01 probability. So that means the interior between the two values should be 0.98. Okay, and there we get our two x values there. See that? We get 20.341 and 25.498. Anything below 20.341 is considered significantly low. Anything above 25.459 will be considered significantly high. Falls outside of that range of 0.01. Okay? So let's go ahead now. Our instructions here, round to 1 decimal place. So if we round those two values, 20.341 to 1 decimal place, we get 20.3. And if we round 25.459 to 1 decimal place, we get 25.5. Okay, so that's our range that we would consider to be proper, not too high, not too low, at the 1% tail probability. So if we use this criteria, is 25.2 inches significantly high? Well, no, because it falls in the thresholds of 20.3 and 25.5. just barely, right? Almost exceeds the higher value, but it doesn't exceed it. It's less than. So we would then answer that a back to knee length of 25.2 is not significantly high because it is inside the range of values that are not considered significant. So that 25.2 value gets out there, way out there in the right side, but it's within threshold. So we would not consider it to be significantly high. Okay. Okay. All right. Here's a procedure problem where we check that NP and NQ are greater than or equal to 5. Okay? Remember, the binomial distribution for sample size n can be used as a potential model, but we have to satisfy these two conditions here. If n is 12 and p is 0.6, 12 times 0.6 is 7.2, which is greater than or equal to 5. However, q here is 0.4, right? And 0.4 times 12 is 4.8. So that fails the check. And this is false. Okay, the student checked false, and that's correct. Okay. Okay, here's our graph. And we want to find the probability that our random variable x, which is IQ scores of adults, which has a normal distribution with a mean of 100 and a standard deviation of 15. So we want to find the probability that the IQ scores fall below 95. Okay? So we're going to find the area in this left tail over here. So let's go to StatCrunch. Our mean is 100. Our standard deviation is 15. And we want to calculate the probability in the left tail, so to speak. So we'll use standard. So we want to calculate this probability here, that x is less than or equal to 95. And there you see, it's, let's see, what do we have to round off here? 4 decimal places. Okay, so let's round this. Let's round this value to 4 decimal places, and we get 0.3694. Okay, that's the area shaded under this normal PDF. Okay. Okay, and the student got that one correct. Find the mean, mu, for a binomial distribution. Mu is NP for binomial. For n equal to 18, NP equals 1/2, and that'll give us 9. Which word is associated with multiplication when computing probabilities? Well, remember the multiplication rule is the probability of A and B, which is the probability of A given B times the probability of B. So and is the correct choice there. Okay, guys, this student did well, probably could have done better had he gone back and checked his answers. So 25 out of 30 is a very good score. The average, so the good news for your practice test was that the average score on this practice test was 74%. Okay, passing grade. All right. And the flip side of the coin was that only 14 people actually turned in the practice test. So most of you did not do the practice test. I gave it to you, I believe, last Saturday or Sunday. So you had plenty of time to work on it. Your midterm, I'll post it on Thursday. I'll give you 24 hours to complete it. So carve out time. Let's see, we won't have a Zoom session on Thursday, but we will have office hours on Thursday.
So is
So
the
you-
midterm going to be like something we print out?
No, it'll be exactly like the practice test.
Okay, so I'll be on StatCrunch.
It'll be in my lab.
Okay.
Yeah, it'll be my lab. And I'll give you the three admits, the three the submissions. So if you don't like your score the first time around, repeat it to get a better score. Okay?
And then is it going to be the same topics that were covered on the practice midterm? Because I know we went a little
Yes.
ahead. So it's
Yes.
not going to be like the little, like you know how we went a little ahead past the practice midterms and learned a little bit more? It's not going to be like,
No, this test covers really chapters 4 through 6.
okay,
Probability,
that sounds,
distributions, and normal distributions.
so the two chapters we should study are 4 through 6. Like the
Three
most.
chapters, 4, 5, and 6.
Or three chapters, sorry.
Yeah.
Okay.
And as you saw here in this practice test, all of the examples were taken out of those 3 chapters. So I'll use the same test bank, and I'll generate same number of problems, 30 problems, and then you'll submit.
Can, by chance, can you put like another practice midterm on MyLab so we could practice some more before the test? Or like, can you make it so there's unlimited attempts for the practice midterm on MyLab?
You don't have any, you've already submitted your test, your practice test.
Yeah, can
You
we get
can.
like another one to practice some more?
I won't promise that because that means that I'll have to gen up 2 tests, another practice test, and then your midterm. I don't know if I'll have time for that, but I'll try.
Okay.
Okay?
Okay.
Again, these practice tests that I give you don't count against your grade. All right?
Okay.
But the other statistic that I shared with you was that the average completion for your MyLab Statistics homework is 47%, which is about right. You know, we're more than halfway through the course, so we'd expect about 50%. But some of you have been neglecting your homework. Some of you haven't been keeping up. And a practice test helps, but it won't fill in your background for this. You should have been keeping up. Some of you have done that. And I saw some very high scores on this practice test. There was a 100%. But the other side of the coin was that only 14 people submitted the practice test. Okay, so the protocol is no Zoom session on Thursday. Look for your midterm test to be posted on the assignments list in your MyLab Statistics assignments. And I'll give you two retries, 3 in total. Okay. The time that students took to complete this exam was less than 2 hours. It's not a long exam. So I'll give you 24 hours with resubmissions to complete your exam. Okay? All right, I'm going to have to end the meeting here, guys. Unfortunately, I can't respond to your chats. Okay, I think that, okay. I believe that the gradebook will grab the highest of your submissions. I don't think it takes the latest and greatest. I think it takes the highest. Okay. So I'll give you multiple submissions, and then gradebook will grab out the highest, and that'll be your grade. Okay. Space your submissions, if you have time, within the 24-hour window so that you can be refreshed when you take it again, if you take it again. Some of you may score, you know, over 70% on the first try. And if you don't want to improve on that, you stand pat. Okay, guys, I'm going to end the session now. And I'll come back in a few minutes for the office hour. Okay?
I'm sorry, Professor.
Yes.
Did you say that you were able to upload the recording of this? I'm sorry, that's my dog, Chanel. Did you say that you were able to upload a recording onto Canvas for us to refer back to?
For this this session here?
Yes, sir.
Yeah, I will do that.
Okay,
I failed to do that for the last worksheet. So I owe you that video, and then I'll post this video as well. Okay?
Okay.
Although remember, worksheets 7 and 8 are confidence intervals and hypothesis testing. That's not covered on the midterm. Just chapters 4, 5, and 6 cover your midterm. So it'll look a lot like your practice test, okay? But I'll get the video up for this one as soon as possible, all right? Okay, guys, see ya.
Thank you.
Thank you, bye-bye.